Today we're starting a new topic called Simplifying Trig Expressions Using Trig Identities. So it's about trig. We're still in the trig unit. I gave you today a pink sheet which has all of the trig identities we're going to be using on it. So we're going to be referencing that quite a bit. So yours is pink, but we've got a couple different kind of identities, reciprocal identities, which you know. The reciprocal of the sine is the cosecant. The sine of x is 1 over the cosecant, and all the others. Now these two we know, or with this one we're very familiar with. What is the tangent? It's the sine of x divided by the x. So making cotangent is the reverse, the reciprocal. Even and odd identities. We have not used these yet, but think about it. The cosine of negative x, so let's say I take negative 2, is equal to the cosine of x, because the cosine are the x values. And you can see on this graph that if I have negative x and positive x, the cosines are equivalent, because they're the x values and they're both positive. They're both positive. The cosine, when x is negative, it has the same value, the positive x. Okay. And the secant, because the cosine signs operate that way, the secant operates the same way. The sine is considered odd rotational symmetry, and let's look at it. If I take the sine of negative x like I took the cosine of x, the sine of negative x is down here. It's, let's say the sine of negative is here. It is equal to the negative, I have to put negative, sine of x, because this would be positive 1, so this would be equal to if I make this negative. So in this way, sine values, the y values, have odd symmetry. We'll have these reference sheets to work from. Cofunction identities we will get to later, so they're there. We will be using these immediately. The Pythagorean identity. So we've got sine squared plus cosine squared equals 1. And we have got any algebraic manipulation of this right on your formula sheet. If I have the sine squared of x plus the cosine of x equals 1, I can move this around. So that, what would happen if I subtracted cosine squared of x? I would get the sine squared of x, subtract it from both sides, it would fall out here, equals 1 minus the cosine squared of it. That is just a manipulation. And if I did if I subtracted sine squared of x from both sides, get the cosine squared equals, I'm subtracting it from both sides, 1 minus the sine squared of x. So those are two manipulations. The other thing I could do is I could multiply this, both sides of this, multiply everything by negative 1. What if I multiplied by negative 1 this equation right here? Well, all the signs would change. So I would get negative sine squared of x, multiplied by negative 1, plus the cosine squared of x, which those are just written, I could write them in here. So that would be the negative sine squared of x equals cosine squared of x minus 1. So the sine squared of x is 1 minus the cosine squared. The negative sine squared is the cosine squared minus 1. So equivalently, if I multiply the second equation throughout by negative 1, I'm going to get the cosine squared of x equals the sine squared of x minus 1. Okay, I'd get negative 1, I'd multiply through, I'd get negative cosine squared x is negative 1 plus sine squared of x, I'd reverse them, and there I would have it. When we're going to be substituting identities, you'll see what that looks like later today. So I'm given on the identity, but all of these things are equally equivalent. Okay, so this will occur with this equation and this equation. We're very familiar with these. Okay, let's go. We have that for reference. So we're simplifying today. We see as we look down this, we have no equal signs. We just have expressions. So we just want to make them simpler. And there are 6 strategies we're going to use. I'm going to make the strategies in black and then work in red. The first strategy is we can simplify fractions. Simplify fractions. So what happens when I do that? Well, I look at this expression and I see that I have 2 sine of x's up here and 1 sine of x down here. So this is equivalent to the sine of x times the sine of x, right? Over, just keep this the same, cosine of x, sine of x. That's what sine squared of x is. It's the sine of x times the sine of x. So what we see is that these 2 will cancel, so this simplifies to the sine of x over the cosine x. But then I can simplify again because I look at my quotient identities and I know that the sine over the cosine is equivalent to the tangent of x. And that is the simplest form I have for this expression. So that's one thing we can do. The next thing we can do is we can write all functions using only sine and cosine. Write all using only sine and cosine. Well, what does that look like? All right, I have tangent of x. I know that that the tangent of x is the sine over the cosine, so let's substitute. So this becomes, I'm substituting the sine of x over the cosine of x multiplied by the cosecant. Well, I look at the reciprocal identity. I know that the cosecant is 1 over the sine of x. So I have written both of these only using sine and cosine. And the great thing about this is when you do that, things will cancel out. So I'm looking at this and I'm multiplying straight across. So I see that these 2 will cancel. I'll be left with 1 over the cosine of x, which that's a reciprocal, so that is equivalent to the secant of x. All right, the next thing we can do, this rule we'll just put in our back pocket for later, is every time you see this expression, pi over 2 minus theta, or x, that's just a variable, pi over 2 minus theta, and what is pi over 2? That's 90 degrees. Right? These are called our co-function identities. When I see that, I use co-function identities. Co-function. Well, let's see what's r. So I want pi over 2 minus theta. What is equivalent to the cosine? Look at my sheet and I say, oh, well, the sine of pi over 2 minus x and theta are the same, just a variable, is equivalent to just the cosine of x. Sine of theta, I've simplified. Remember, that's where next. We can look for Pythagorean identities. Look for identities. All right, so looking at my pink sheet, do I see anything I can substitute? Look at my sheet. 1 plus the cotangent squared of x is equivalent to the cosecant squared. So I can take this out and put this in. Let's do it. So now we have the cosecant squared of x. I've made that substitution times the cosine squared of x. Well, then I think, I remember just a few lines up, we said we could write everything in terms of sine and cosines. Do that. How could we simplify the cosecant? Well, that cosecant squared is equal to 1 over the sine squared of x, and then it's multiplied by the cosine of x. Oh, well, this is just going to be the cosine squared over the sine squared, which I just saw was cotangent. But they're squared, so my answer, this is equivalent to the cotangent squared of x. And so it's just substituting, multiplying. Okay, and the next strategy is a simple algebra rule that you already know. Dividing, this is kind of just a reminder. Dividing is the same thing as multiplying by the reciprocal. And I should say dividing because we're now using trig functions, right? So dividing by a function is the same thing as multiplying by the functions its reciprocal. So it works for fractions, it works for functions. So I'm dividing here. This is equivalent. This equals the cosine squared of x. Secant is the same thing as multiplying, I've got the numerator up there, by the reciprocal denominator. So let's just rewrite this before we do the multiplication. Write this as 1 over the cosine is 1 over the cosine of x. All right, I just wrote the secant as and now I'm going to say this division. How do I do that division? I take the numerator and I multiply by the cosine of x, not squared, over 1. Okay, so substituted, and then I reciprocal to get the cosine cubed of x. Simpler than that. So, one more. This, you see, these look, ugly, complicated. It's just a fraction, okay? And so we can fractions, and combine is another word for add and subtract. Okay? We can add and subtract fractions by using common trig function. So it looks like, oh no, it's just a fraction. It already denominator. So what do? I write the common denominator and I combine the numerators, which is sine squared, cosine squared of x. Now I see, oh look, I remember that's a trig identity, a Pythagorean identity. 1 over the cosine, and look at that, that's a reciprocal identity. 1 over the cosine is equal to the secant. So I just keep using these strategies until I get as simple as I can for today, and then we're going to practice with you, and then you finish the rest and bring it in for homework. So, practice. What can I do? Well, everything is already sine and cosine. So, I can simplify. A sine divided by a sine, that equals 1. Anything divided by itself. There's 1 cosine here. There's 3 cosines in the bottom. So that will simplify to 1, and this will be reduced by 1. So I will be left with 1 over the cosine squared of x. Well, that's a reciprocal function, so that's equivalent to the secant squared of x. Let's do another. I'm going to think of which ones would be. Let's do the next one. Cotangent times the secant. Well, I look at that and I think, oh, I don't like reciprocal functions. Let's think is sine and cosine. The cotangent. I think tangent, sine over cosine. So cotangent must be cosine of x over sine of x. Of it, I just look at my pink sheet, times, what's the secant? Well, the reciprocal is the cosine, so 1 over the cosine of x. Now I'm going to multiply them. Cancel these, which will give me 1 over the sine of x. The reciprocal of that is the cosine of x, and so much simpler. Okay, go ahead, keep practicing, and bring in your work and check it tomorrow.